Hey, grade eights. On to we're on section 9.2, chapter 9, section 2. And textbook sort of, I feel like, jumps around a little bit in what they're trying to teach. So in my mind, what you need to understand is that we're looking at representing linear patterns, and we can do that in three ways. And you're going to have to sort of be able to jump from one way to another. But I'm just going to do that by looking at a pattern. So here we have a pattern with matchsticks. We can call each of these a figure. So this can be figure 1, figure 2, and this could be figure 3. Okay, and there's a bit of a pattern happening here. In figure 1, we have 3 matchsticks that make one triangle. In figure 2, there's 2 triangles. In figure 3, there's 3 triangles. We could assume that this pattern would continue. In figure 4, there'd be 4 triangles. They would add on another matchstick here and here to make 4 triangles. And that could just keep going. So that could be a pattern that would continue. So in figure 1, we have 3 matchsticks. Figure 2, we have 2 more matchsticks, so 5 in total. In figure 3, we have 1, 2, 3, 4, 5, 6, 7 matchsticks. Okay, so we can show this pattern in a few ways. Okay. So one way that we can do it is with a table of values. So a table of values compares usually at least 2 sets of data. So in this case, we could do figure number or number of triangles, either one. So figure number. And in the other one, we're going to compare the figure number to the number of matchsticks needed. Number of matchsticks. Sounds weird. Matchsticks. Okay. So in figure 1, how many matchsticks did we need? 3. In figure 2, how many matchsticks? 5. In figure 3, there was 7 matchsticks. And we could actually continue this table of values, assuming that this pattern continues. Figure 4 would have 9. Figure 5 would have 11, adding 2 each time. Okay, so this is a table of values, one way that we can show this relationship. Now, another way that we can show a linear relationship is with an expression or an equation. The easiest way to figure out this expression showing the relationship between figure number and matchsticks is actually to use our table of values. So making a table of values is very, very useful. What you'll be needing to do a lot this section and really just this chapter. So essentially, we're trying to say, well, how can we show this relationship to the figure number to get the number of matchsticks? Or what math are you having to do to get the number of matchsticks from your figure number? So for instance, what if I said, well, how many matchsticks would be in figure number 12? How could you figure that out without actually having to just continue your table? Or what if I said, how many matchsticks would be in figure number n? Okay, so we did this in grade 7, some of you might remember, but we have this variable here now. So what would we have to do to that variable? What would we have to multiply or add or subtract to the figure number to make it equal to the number of matchsticks? So there's 2 things that are important to look at. One is how much are our values going up by. Okay, I'm just going to change color here for a second. Okay, so our figure number is going up by 1 each time. Okay, that's going to be the easiest way. If you have one of your values going up by 1, it's going to be the easiest for you to figure out what this expression or equation would be. And then you look at the other one. So for every one figure number, every time we change a figure number, how much does our number of matchsticks go up by? Well, the number of matchsticks goes up by 2 each time. So how much this goes up by each time, even though when you go from one figure to the next, you're adding 2, it means that for every figure number, you have 2 more matchsticks. So this actually shows how much you're having to multiply. So we're going to have to be multiplying 2 times by n, what is the figure number. Okay? But does that work here? So if I have 1, the figure number 1, if I multiply it by 2, that's equal to 2. But my number of matchsticks is 3. If I multiply 2 by 2, I get 4, but the number of matchsticks is 5. So just multiplying doesn't work. So after figuring out what you need to multiply by, you can either just look and see, well, what else do I need to do? Well, 1 times by 2 is 2, plus 1 is 3. 2 times 2 plus 1 is 5. So 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, plus 1 is 7. Okay, so now I see that I have to add 1. Okay, so I can just sort of do some checking and looking at how much it's going up by. So my figure number at any point, I just need to multiply it by 2 and add 1 to get how many matchsticks I would need for that figure number. So for figure number 12, I would multiply it by 2, that's 24, and add 1, so 25 would be how many matchsticks I would need to make figure number 12. The other way to figure out what you're adding or subtracting is to actually go backwards in your pattern to get to figure 0. And if I go backwards from 3 down by 2, I get 1, positive 1. And so I'm adding 1 at the end because it's positive 1. Okay, and so our expression that shows this is, the number of matchsticks in terms of the figure number would be 2n plus 1. You could also say, if n is figure number, and m is number of matchsticks, you could say the number of matchsticks m is equal to 2 times the figure number plus 1. So this would be our equation. Now that there's an equal sign, that could be an equation that we could show the relationship. Okay, the third way that we can show this relationship is with a graph. So again, using our table of values. So making a table of values from a pattern is very useful, very important, because it's how we can find the expression. It's also how we can make our graph. So each one of these numbers together, and sorry that this is getting so messy, but each one of these numbers together, the figure number and the number of matchsticks that goes with it, those make ordered pairs. Pairs of numbers that go together. So there's always 3 matchsticks in figure 1, 5 matchsticks in figure 2. So those numbers go together. So we can use them as ordered pairs on our graph. So I'm going to have figure number be on my x-axis, and I'm going to have my number of matchsticks be on my y, number of matchsticks. Okay, you guys get the point. That's very messy. And now I can compare these. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go, I'll go up by just 1, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's switch to red. Okay, so when the figure number was 1, we had 3 matchsticks. So when we were at 1, there was 3 matchsticks. Figure number 2, so I go to the 2 on my x-axis, there was 5, and I put the point at 5 on the y. So there's 5 matchsticks. Figure 3, there was 7. Figure 4, there would have been 9. Figure 5, there would have been, 11. That would have continued. And now we can graph all of these points. And we see that these points, they all make a straight line. They line up in a straight line on the graph. That tells us that this is a linear relationship. If they don't make a straight line on a graph, it's not a linear relationship. There might still be some type of relationship, but right now we're just looking at linear ones. So ones that grow and continue in a consistent pattern, the same amount each time. Okay, so table of values, expressions, equations, and graphs. We did do all of this in grade 7, if you remember. That was a while ago, though. Okay, so we'll just do a few more examples. Here we have a pattern. We could call this figure 1. Wait, too thick. Figure 1, figure 2, figure 3. Okay, we want to figure out, well, how many, let's say in figure 22, how many circles would be in figure 22? Well, let's make a table of values comparing figure number to number of circles. Okay, this is one way, using our table of values is one way we can show this relationship. Well, in figure number 1, I'm going to leave space for 0 here actually, but in figure number 1, we had 1 circle. In figure number 2, we added 3 more circles, went up by 3, and we had 4 circles total. In figure 3, we added another 3 circles, and now we have 1, 2, 3, 4, 5, 6, 7, going up by 3. Makes sense. And we could continue this in figure 4. If this continues, there'd be another 3 circles, so we'd have 10 circles. In figure 5, we'd have 13 circles. But we don't really want to just keep making our table of values really long until we get to table 22, or to figure number 22. So let's say, what if we had n figure number? What do we have to do to figure n to make it equal to the number of circles? Well, the two things we look at: how much is our value going up by for every one figure number? Well, it goes up by 3. It goes up by 3. It goes up by 3. That means that as we went up 3 figure numbers, it would have been 3 times by 3. So we're multiplying. This shows us how much we're multiplying by, because for every figure number, we're getting another 3 circles. So that shows us that we're having to multiply the figure number by 3. Okay, 3 times n. How does that work? Well, no, because 1 times 3 is 3, not 1. 2 times 3 is 6, not 4. So we can just do some checking. So 1 times 3 is 3, but I have to have it equal 1, so I'd have to subtract 2. 2 times 3 is 6, but I have to have it equal 4, so I'd have to subtract 2. 3 times 3 is 9. If I subtract 2, I get 7. So subtracting 2, I can just check and see that, okay, I have to multiply by 3 and subtract 2. Or I can go backwards in my pattern to figure 0. If you go to figure 0, that tells you what you're adding or subtracting at the end. So if I was at 1 and I have to go backwards 3 from 1, that brings me to negative 2. And so that's why I'm subtracting 2. Because we can sort of imagine at figure 0, before our pattern began, we would have had negative 2 circles. Okay, so you check how much you have to multiply by how much your pattern goes up by each time for every figure number or whatever else you're comparing it to. And then at figure number 0, or at 0 for the x value, that will show you what you're adding or subtracting. And now, if this is what we know, that we have to just multiply the figure number by 3 and then subtract 2, well, if we're looking for figure 22, we have to multiply it by 3, which would be 66, and subtract 2. So there'd be 64 circles in figure 2. Okay? Well, let's keep going. Okay, so what is an equation or expression that shows the relationship in each of these tables of values? Okay, so this one, the a value, which is, since it's first, it's sort of like our x value. B is our y value. It's going up by 1 each time. Good, that's what we sort of need to be able to see this. So for every one x value, y is going up by 3. This shows that we're going to have to multiply by 3. Okay, and we look, well, x here times by 3, well, that equals 3. 2 times by 3, that equals 6. 3 times by 3, that equals 9. So all we're having to do is actually just multiply by 3. And so this equation that we could make is that y, our y value, is equal to 3 times our x value. So y equals 3x would be an equation. Because we're just having to multiply this x value by 3, and we get our y value. Okay, what about here? This time we're just going to use p and q. We're not going to turn it into x and y. So p is going up by 1 each time. Okay, that's good. That's what we need to see. And if it wasn't, you would have to figure out what would be in between there to make it go up by 1. But in q, goes up by 7 to 13. 13 minus 7 is 6. 13 to 19 is another 6. 19 to 25 is another 6. Okay, so now I know that I'm going to have to be multiplying p by 6 to make it equal to Q. So Q is equal to 6 times by P. Now just be careful, sometimes it's easy to get those mixed around, and you might be like, okay, well, P is equal to 6 times by Q. But when you look at it, that doesn't really make sense, because if Q is 7, 6 times 7 is 42, not 2. So it wouldn't make sense for it to be P is equal to 6Q. So you just got to double check that you have your variables in the right place. But Q is equal to 6 times P. Now still this doesn't actually quite look right, because 2 times 6 is 12, not 7. But let's go back to, let's keep going backwards. So if we went back to 1, and we went backwards 6, 7 minus 6 is 1. Okay, and then if we went back to 0, 1 minus 6 is negative 5. So we're having to subtract 5, 6p minus 5. So let's check if that works. So when p is equal to 2, 6 times 2 is 12, minus 5 is 7. Yay, it works. Okay, when p is equal to 3, 3 times 6 is 18, minus 5 is 13. Perfect, this expression works. 6 times 4 is 24, minus 5 is 19. 6 times 5 is 30, minus 5 is 25. So here's our expression. Q is equal to 6 times P minus 5. Okay, hopefully we did do this in grade 7. It is a little bit of a challenge sometimes finding these expressions in the tables. You can always do a bit of guessing and checking to see what you need to do, but always start with seeing how much your one value is going up by each time, and that's what you're going to need to multiply by. Okay, just real quickly here, are these relationships linear? That's all we're asking. Are they linear? Okay, you can actually, we can graph things to see if they're linear, if they go up in a straight line on a graph, but you don't always have to graph it. What you're seeing is, are the values continuing and getting larger at a consistent amount? So you have to look at both values. So x is going up by 2, by 2, by 2, every time. Adds 2, adds 2, adds 2. Is my y value also going up a consistent amount? Doesn't have to be going up by the same amount. 3 to 7 is 4. 7 to 11 is 4. 11 to 15 is 4. Okay, so my x values are going up by a consistent amount each time. My y values are going up by the same amount each time. So yes, this table shows a linear relationship. In table 2, let's check. Goes up by 1, goes up by 1, goes up by 1. Okay, so my m value, that's linear, that's going up by the same amount each time. But let's check n. It goes up 1 to 4 is 3, 4 to 7 is 3, 7 to 8 is only 1. Okay, so since this suddenly changes here, that's not linear anymore. It has to be a consistent same thing for every one move up of m. It should always be the same amount going up of n, but it's not in this case. It changes, so this table is not linear. Okay, so you can always just check on a table of values if that relationship is linear just by seeing, are the amounts consistently going up by the same. Okay, just quickly here, type of question you guys might get. So use a table of values in solving a problem. So Photo World, you go to a place to print some pictures. They charge $3 for the first enlargement. So you have a photo, you want to get some larger sizes of it. It's $3 for that first enlargement, and then $2 for each additional enlargement. Okay, so let's make a table of values showing the cost in relation to the number of enlargements you buy from 1 to 5. Okay, so number of enlargements is one thing we're looking at. Number of photos. And then we're looking at cost, the dollars. Okay, so when it says if you get just one photo enlarged, it's $3. And then it's only $2 for everyone after that. So if you get 2 photos enlarged, it's going to be another $2. So we're going to go up to $5 total. If you get 3, we're going to go up another 2 to 7. If you get it 4, it's going to go up to 9. If you get 5, it's going to go up to 11. So is this a linear relationship? and then it says y. So when it says y, you just need to explain why you know. So we could look at this and see, okay, well, it's going up by 1, going up by 1, going up by 1, going up by 1. And here it goes up by 2, goes up by 2, goes up by 2, goes up by 2. So yes, it's a linear relationship because the number of photos and the cost are each going up a consistent amount, the same amount each time. Okay, that's how you could show that it is a linear relationship. You could also graph it and make a straight line to show that. So C, what is an expression for the cost in relation to the number of enlargements? Well, we're paying $2 for every enlargement here, and we're going up by 2 each time. So if we were going to get, let's say P number of photos, what is the cost going to be? What is the cost going to be? Well, it's going to be 2 times the number of photos. So there's $2 for every photo you're getting, except that first photo you had to pay $1 extra. And so we paying $2 per photo, but plus the $1 extra that you paid on that first one, because you paid $3 on that first one. Remember, we could also go back. We will go back 1 to 0, 0 photos, and we go back 2, because we're following this pattern backwards. 3 minus 2 is 1. It sort of shows that for 0 photos, you still have to pay $1, which doesn't really make sense. You wouldn't have to pay $1 to print 0 photos, but there's that extra dollar charge, and so that's why we're having to add 1. And so the cost is equal to, as an equation, the cost is equal to 2 times the number of photos plus 1. And so if we're looking at D, what is the cost of 15 enlargements? Well, if we need 15 photos to figure out the cost, we can just put that in for P. So 2 times by 15 plus 1. So the cost is 2 times 15 is 30 plus 1. So the cost would be $31 for 15 enlargement photos. Okay? So that's how we can, we're using this table of values, and then from that table of values we can find this expression, and then using that expression we can find values for much larger values without having to just continue on making a really long table of values. Okay, so that's section 9.2. There'll be an assignment on Google Classroom. Let me know if you have any questions.